I'm Laura Ludwig, and this is the Data Visualization module. During this module, you will learn the why and when to use visualization. We'll also talk about how to use a story as part of your data visualization. We will discuss some basic chart types and the typical uses for them. And finally, we will talk about the technologies that we at Unify typically use for doing data visualization work. So why is data important? In our digital age, it has become increasingly important for businesses to use and process data to get their work done. For one, we need to look at information, insights, and recommendations. Let's take Netflix, for example. Netflix recommends your next weekend binge show based on your data. Having the upper hand with new information allows companies to innovate competitively. Johns Hopkins Hospital has successfully used data to reduce the patient wait time in their hospitals by up to 30%. It's also a goal that companies have to disrupt new markets. A great example of a disruptive company is Uber. They use data to connect citizen drivers to riders, turning the taxi industry on its head. Being able to better target our products to our customers is also a huge opportunity for businesses. Groups like Trunk Club and Stitch Fix personalize style for individuals based on data. In order to be able to do all of these things, though, we have to have data and we have to know how to analyze it. So, what is data visualization? Think about it for a moment. I'll wait. Do you have a definition? I'll give you ours. We consider it the graphical visual representation of data information. The great thing is we use data visualization every day. I bet you've looked at it either today or yesterday when you got in your car. You have a car dashboard and it tells you really important things like, am I going to get a speeding ticket because of how fast I'm going right now? It'll also tell you things like, do I need to stop for gas on my way to work tomorrow? Take, for example, this picture of an Aston Martin. In high-end Aston Martins like this one, there's a digital display of our car that can highlight where problems might be. So I'm not James Bond and I don't drive an Aston Martin to be able to tell you exactly what this means, but you kind of get the idea. How about a visual like this? This map shows the route from Leavenworth to Kirkland. Maybe if you were out visiting Leavenworth for Oktoberfest, it's not so important to find somewhere to eat on the way home. But I promise you, after a day of climbing rocks out near Leavenworth, you're going to want to find something to eat. On the left, there are options for where we might stop with some high-level information about the ratings and general category and the opening hours. That will help us make a decision, although, but let's be real. When pizza is an option, is there really any other choice? So we know that data is important, and we now know what data visualization is. But why would we use data visualization? Instead of me telling you, I want to demonstrate it. So I'm about to show you a grid of numbers, and they're all digits, and I want you to tell me which one occurs most frequently. Ready? Did you get the answer? How confident are you about that answer? Now we're going to do the same thing, except I'm going to show you this information in a slightly different way. Here we go. That was so much easier to figure it out, wasn't it? Our brains process information in a visual way much faster than they do with text. And this is why we like to use data visualization in a business context. That was a pretty simple task, and business data is often much more complex. So let's take a look at how some visual cues help make decisions at one of our clients. We'll take a look at T-Mobile. T-Mobile began offering a special plan for military families in the spring of 2018. It's basically 50% off their T-Mobile One plan. It's a pretty great deal. The way this works is that a customer goes into a store and tells the rep, hey, I'm in the military. The rep adds the discounted plan to the customer's account. So far, the customer has not had to do anything to prove their military status. But T-Mobile can't just give away their services at a discount to everyone who claims to be military. That's where verification comes in. An online portal was set up for customers to verify their military affiliation. In many cases, that verification requires a document, and most customers don't walk around with that on them or have access to it on a mobile device. So they have to do it at home. Customers have 45 days to complete their verification, which that's plenty of time, right? Well, we all know how those things can go. It's always the easy things that we forget to do. T-Mobile's solution was to send SMS reminder messages through the 45 days to help customers complete their verification process. These messages were scheduled to go out on day 3, day 15, and day 38. So what is T-Mobile going to be interested in monitoring these messages for? Well, for one, T-Mobile doesn't own the system that actually sends these messages out. So the first thing we want to know is, are these messages going out? That's exactly what this dashboard looks at. The gauges on the left give us a quick indication of whether all the necessary messages are getting sent out. The target was 85%, but only about 75% of customers actually got their message. This quick view told the product managers that something was wrong with the system that was sending those text messages. They were able to address the problem with the vendor who owns the system, and we can see the results in the trend line on the right. The message send rate earlier in the trend is lower, and we can see that the average looks like it increased in mid-July after the problem was fixed. Because a KPI was lower than normal, we were able to take action to fix it, and we can see the evidence of that in the visualization. If we'd been working with raw data, it would have been much more difficult to figure out that there was something wrong and we needed to take action. So we've seen some examples both from our personal lives and some ways that we've used data viz at clients. Now let's actually talk about how data visualization is used in a business process. The most important part of any data visualization is using it to tell a story. Humans are wired for stories. Throughout history, we have used stories to transmit information. Fables and fairy tales taught us important lessons as children, and we remember the story much longer than a lecture in a classroom. Every good story has a beginning, a middle, a climax, and an end. Let's take Goldilocks and the Three Bears, for example. In the beginning, there's an empty house and Goldilocks is walking in the woods. In the middle, she goes into the house and she starts trying everything in the house, the porridge, the chairs, the beds. Then she falls asleep in one of the beds. The climax of this story is the bears come home and they discover her. Our ending is that Goldilocks runs away. What do we learn from this story? We learn that we should never break and enter. So that was fun, but how does that relate to data visualization? Well, I'm going to teach you a concept that I call the 4 C's. And this is exactly how we relate data visualization to a story. The first thing that we have to consider is our context, and that's the equivalent of the beginning. This is setting the stage for what we're about to solve for. It's information about the problem or clarifying the question that needs to be answered. Next, we can raise the stakes in the data visualization by bringing in our content, which is the data and that we're presenting. The climax is the conclusions that we want the user to find. We may guide them to these insights in a variety of ways, like I did for you by putting the count of digits into a graph. Once we've gotten our users to discover the key information, we want to bring them to the end. The end of our data story is related to the consequences or actions that we want our users to take. These should be natural responses from setting the context really well at the beginning, and they should be immediate actions that the user doesn't need to even really think about. So there we have 4 C's. We have context, content, conclusions, and consequences. We're going to use these 4 C's to look at some visualization stories. Let's come back to the T-Mobile story that we looked at a few minutes ago and apply the 4 C's to it and see how that works. What was the context for this visualization? We have a new plan that's offering military members a huge discount. We need to verify these people getting this plan are eligible for it. The customers need to complete a step at home after leaving the store, so we want to remind them to do that. So how about content? We have the message send rate as a KPI, or key performance indicator, that gives us a quick way to see that we're not sending as many messages as we expect to be. We can also see that it was consistently low during June into July by looking at the trend. For conclusions, we saw a low KPI, so we know that something is wrong. Looking back, we can see now that whatever happened in July fixed the problem. As for our consequences, we were able to see from the early KPI value that we needed to fix the messaging, so we tasked the vendor with fixing it. Now, we might be interested in trying to figure out what these drop-offs are. Could it be that there's a system outage every couple of days? Or is there some kind of scheduled maintenance? We don't really know. On to the next iteration. Even within telling a story, we have multiple different types of conclusions that we might have our users come to. Some of these types of conclusions might be things like explaining an answer to a question and what happened in the past versus kind of exploring a new idea and coming up with new questions of what we might want to understand from our data. First, let's take a look at explanatory data visualization. This is visualization that is used to answer specific types of questions, like, how much did we do in sales last quarter? How does that compare to the same time last year? What products had the most frequent stockouts? Explanatory analysis starts with a question and uses a visualization to answer that question. Ultimately, that question should drive the business to actually do something. Usually with an explanatory analysis, the hardest part is getting to that really good question that we're trying to answer. Here, we have an example of an explanatory visual showing the breakdown of Nobel Prizes awarded by gender and category. The visual could be used to answer questions like, which category award has been given out the most? Or, which Nobel Prize has more female winners, economics or literature? If we're doing research about the diversity of successful people, we might need to decide what category to focus on. The other main category of analysis is exploratory analysis. In here, we are exploring and discovering new insights within our data. We're going to find new questions, and we're probably going to find that we need some additional analysis techniques to understand it even more. Data visualization, in particular exploratory analysis, is iterative by nature. Here, we have an exploratory analysis about Nobel Peace Prize winners. There are lots of dimensions that we can see here. The year that the award was given, the gender and the number of winners, the geography the winners come from. Questions such as, how many women have won the Peace Prize are answerable, but they take a lot more work to determine. Instead, we can see that there's a greater variety in color as we go down the visual. That tells us that the Peace Prize has been getting more diverse in geography over time. We can also see that there seem to be more of these little eye symbols showing up, especially in the last 14 years on the chart. So we might ask some new questions. Are there more institutions winning in the recent past? What might be causing this? Could it be things like think tanks and the internet versus individual researchers? The questions that come out of an exploratory analysis are often more complex than what we can answer with simple data analysis. That's where data science comes in. For example, here we have a chart looking at e-commerce returns due to damages. We might use data science to investigate whether this peak here is a statistical outlier or just noise in the data. We might want to look more closely at these two products to determine if there's a common feature or characteristic that causes these items to be returned damaged. Amazon did exactly this. After noticing that certain products were more commonly being returned as damaged, they worked through a data science project and figured out that there were certain combinations of items that shouldn't be packed together. For example, you don't want to pack a poster and a new picture frame. The frame is going to crush that poster if they're packaged in the same box. Finally, data viz is commonly used to present the findings of a data science analysis. Like we talked about, pictures are much more accessible than words or complicated statistical outputs. So often we will use dashboards to present those findings. An example would be the dashboard that Dave presented in the earlier module about the customer lifetime value at Bing. That output was much more accessible and actually usable by the business because they put it into a visual format. So now we've talked a little bit about what visualization is and why we would use it, but now let's talk a little bit about how actual people use it. Just like we wouldn't tell the same story to a 6-year-old as we would to an adult friend, we don't tell the same data story to all of our different types of users. We can categorize our audiences into 4 main groups. The first one is scanners. Scanners are the people who are looking for the highlights. They want the too long, didn't read version of the important information. Executives often fall into the scanner category. They want to see the biggest highlights quickly. It's important to identify good KPIs, remember that's key performance indicator, for this audience. They need to give clear indication on the health of a project or organization in one or a small set of numbers. Our second set are our questioners. Questioners are more interested in the content. They may be looking for an answer to a specific question, or they may be looking for a detailed story to support the current status of a KPI. Business managers often fall into this category. They'll be interested in trends and outliers to support the broader story around the KPIs. They may be called upon to tell that compelling story to executives in more detail, especially if the KPI is not being reached. Our third group are our researchers. They are often experts on your topic and your data. They'll be interested in understanding how the analysis was conducted, and they might want to dig into proving the conclusions or have new questions. Analysts are often the researchers in an organization. They can see the conclusions that are drawn from the visualization, and they need to explore record-level data that supports the visualization and answer new questions. They often do their own ad hoc analysis on the same data. And finally, we have our operators. These are people who consume visualization with the intention of completing their daily tasks or monitoring systems. Workers such as cashiers, sales representatives, and operational engineers fall into this category. They will want to see alerts when things deviate from the normal situation, or when there's some sort of exception. For example, if a server rack is too hot, the data center engineer would get an alert to investigate the problem. These are by no means an exclusive set of the visualizations that these different groups will use. Often, this is just a guideline, and this is where we start from in our recommendations, but there's a lot of crossover between what people will use. Let's take a look at some examples of how unifiers, both at our client sites and internally, might use data visualization in their roles. Project managers track hours worked and project spend to maintain timely project delivery on budget. Business development can track leads, comparisons year over year, individual revenue generation metrics, and their key accounts. Scrum Masters use agile dashboards to track burn down rate in a sprint for both story points and hours, among other agile specific KPIs. So I think we're convinced that data viz is a good thing and that everybody can use it in their roles, right? So let's take a look at some basic chart types and how we can use them to answer different kinds of questions. Let's take a look first at what makes a really good chart. The first thing is telling a good story. We've already talked about that. The other important thing about telling a story is that we're telling a true story. So we need to accurately represent the data the way it is in the data set. Once we have a good story that we want to tell, we want to choose the right chart for the right job. We want to be able to guide our users to make the right comparisons and be able to draw the conclusions that we want them to draw. We're going to talk a little bit more about these detailed basic chart types here in a few minutes. When we build a chart, we need to make sure that we're using good chart grammar. What is chart grammar? Well, just like we have grammar in our spoken language that tells us what the structure is and what words should go together and how we construct our sentences, we've also got some key components within visualizations that we can use to do the same thing. These include things like titles, axes, legends, and just overall communicating the right information. We also want to make sure that we're not distracting our users with what we call chart junk. What is chart junk? Well, chart junk is just extra stuff that doesn't help us tell the story. This includes things like using 3D elements in our graphs when we only have two-dimensional data. It can also be things like extra graphics or making it cute. We don't always need those things. And so when we don't need them, it's called chart junk. It is often tempting to use color as part of our data visualizations and just to make them pretty, right? But that can easily become a distraction and contribute to that chart junk that we were talking about. We want to make sure that any colors that we use help contribute to telling our story. We can use color to encode categories or different levels, as we'll talk about when we look at heat maps. One of the things that we want to make sure that we're cognizant of is that there are people in the world who can't always see all the same colors as we do. So we need to be really careful when we pick a color palette. We want to make sure it's easy on the eyes for everybody who's looking at it. And we also want to make sure there's enough variation so that people who are colorblind can still get the insights that they need from our visualization. Now that we know some of the basic components of a good chart, let's take a look at some bad charts and see if we can figure out what's wrong with them. So this first one is all about commuting, specifically modes of transportation by city. Well, first, does this graph tell a story? Maybe. Without knowing the story we're supposed to take away, it's kind of hard to know the right chart type though. Well, does this chart use good chart grammar? Well, no, it doesn't. It has a title and a legend, but there are no axis labels. The premise of this chart, filling in the letters of the city, can be classified as junk. It's cool looking, but overall distracting. The colors are helpful here, but the choice of partially a gradient and partially color difference is really confusing to identify the different categories. Sticking with either a gradient or distinct colors would have probably been preferable. Here's another one. The story they want to tell is right there in the title. Sales are strong, prices are going up. But is it a true story? The numbers in this visual are not connected to the sizes of the graphics. Compare the bar size of 2014 to 2015. According to this visual, 7,222 is larger than 7,494. That's just inaccurate, and the graph distorts this reality. This chart does not have good grammar. There are no axes to refer to, and it ends up making these charts very deceptive. The size of the bars and the money bags do not scale with the values. The arrow is redundant, which makes it chart junk. The combination of colors in the background is just not easy to look at, and overall, this is just not a good chart. If you're so inclined, pause the video here for a minute and sketch out how you might fix these charts. For more examples of bad visualizations, you can check out viz.wtf. Go ahead and take a look at some of those pie charts and be thankful that you didn't make them. Now let's take a look at a good chart and apply these principles and see how they work. This is an example from flowing data about education deserts. Looking for a story, this map highlights areas where there are a number of residents who live at least 60 minutes from a college campus. There are pockets with less access, and that's an important story because if we're working on an online learning platform and we want to increase access to higher education, we're going to want to market to those areas. Since we're talking about distances and geography, a map is a really good chart selection. We have a clear key at the bottom, and we don't have any extra stuff cluttering our map. The color scheme uses hue saturation to indicate the density of a problem, and it adds value by showing different colors. Overall, this is a really good graph. Now that we understand the anatomy of a good chart, we want to get to building some cool visuals, right? First, let's ground ourselves in some common vocabulary that we use when building charts. We'll use this home listing to understand the different types of information that we might want to display on a graph. The first is a dimension. A dimension is qualitative, typically showing categories, and they can't be summarized using math functions. In our example, the year the house was built is an example of a dimension. It wouldn't make sense to sum up the years to tell us something about the real estate market, but the year is a way that we could filter or slice our data. Next is a measure. A measure is quantitative. Typically, it's a numeric value, and it can be summarized using math functions. In our home listing example, the price and the square footage are good examples of measures. We can sum these or take the average across multiple home listings to understand the real estate market area. What about the number of bedrooms and bathrooms? They're numbers, so are they measures or are they dimensions? Surely, if we're looking at the entire real estate market, we could probably do an average or a sum if we wanted to understand the average number of bedrooms in a particular community. But most of the time, real estate agents use these as categories and say, oh, that 4-bedroom over there is really nice. This is one of the reasons that understanding our context is so important, because when we use it as a category, that is a dimension. Now it's time to take a look at some basic chart types. But as I've been emphasizing this whole time, understanding context is really important. So let's make up some context for these basic charts. Here's our context for these simple graphs. We have an imaginary company to talk about. Let's call them Pear Inc. Very creative, huh? They sell phones and tablets and watches and accessories. Internally, this company has 4 sales regions: North, South, East, and West. We'll use these to look at sales of their products as we walk through our example graphs. Bar charts, also sometimes called column charts, are our first chart type. Bar charts are generally used to show one measure compared across one or more dimensions. Remember, dimensions can be categories. They are used to answer questions such as how many or how much is in each category. In this case, we have total sales by region. This is the simplest form of a bar chart, where we have one category and one measurement. We can see that the West is doing the highest sales and that South has the lowest. What if we want to see which product is doing the best in each region? This would mean that we are looking at 2 dimensions across one measure. We have several different varieties of bar chart that we can use to answer these types of questions. The first being a grouped bar chart. It still shows the sales by region, which are grouped together, but now we have multiple bars, one that shows the amount of sales for each product, and that's indicated by our color. In this one, we get new information about which products generate the most sales, but it's harder to see which region is doing the best overall. If we want to see both the total sales and how the products do in each region, we can use a stacked bar chart. This takes those bars that we group together and piles them on top of one another. This allows us to see the overall sales and which products are doing the best in each region. If we're interested in seeing how our sales have changed over time, we're going to use a line chart. Here we have a line graph showing the trend of 2017 sales for the West region. But what if we care about all the groups, not just the one region? We can draw additional lines to show the trends of the other regions, shown here by different line colors. As we're trying to figure out what happened in a given region, it might be useful to have some more information about what happened during a given time period. This is where a timeline is a good visual. These are often used in parallel with a line graph, and they help explain why a change is seen in the trend in the data. Here we have some info telling us about what was happening in the North region, and we can translate those events to things that happen in the dark blue line in the line graph above. Area charts are a lot like line graphs, but they have all of the area underneath filled in. Like line charts, area charts typically represent changes over time. The main difference is that an area chart represents the total volume of the measurement, not just the point-in-time trend values that a line chart shows. In this example, we see the overall trend for the North region, represented by the top border of the shaded area, and the shaded area underneath represents the total revenue over that entire time period. Area charts can be tricky though. When we add the South region, we can't actually see what's going on in that region specifically, since the North region is covering the trend of the South. The most common way to deal with this is to make our visualization transparent. This lets us see the data trend for both regions, one on top of the other. Up to this point, our only measure has been the total sales. But what if we have two measurements that we want to compare against each other? Enter the scatter plot. Scatter plots are used to look at patterns in the relationship between two measures. Sometimes these relationships are linear, like we see here, or they might show clusters or outliers. In this example, we have the average number of employees working in a store compared to the total number of items sold by that store. We might use this to figure out if we have an appropriate staffing level, like if we have a lot of sales in a store but only a few people, are they overworked? Or are they doing things efficiently that we could study and learn from? So far, we have only seen scatter plots using measures, but what if we have a dimension that we want to include? This is where we can use color and/or our shape to indicate different dimensions. Here, we've used color and the shape to highlight which stores reside in what regions. We could use shape for region and color for another dimension if we wanted to, but be warned, the more facets you add to your chart, the more time your viewer has to spend figuring out what it is you're trying to tell them, so be mindful of your story. Taking our scatter plot one step further, we can encode a third measure. The way that we do this is by changing the size of the shape that we're plotting. When we do this, it gets a special name. It's called a bubble chart. We can continue to use color as a way to encode one of our dimensions. But because we're changing the size of the shape, it's best to leave the actual shapes the same for comparison purposes. So we do lose the ability to use two dimensions in this chart. In this example, we have total sales as our bubble size, and we've shifted to only use color to show the region. And now, for our final chart type, we'll take a look at the pie chart. Pie charts look at the composition of a whole. Our example, we'll be looking at the total sales for one region and seeing how it's comprised of each of the different product types. Time for some truth. Pie charts often get a really bad rap in the data visualization world. Why? Well, it's because of how our brains work. We don't process angles very well to make comparisons. In our example here, all of the slices look relatively equal. This is a valuable observation, but I can't really get any more specific in any comparisons without some extra help, such as data labels. Pie charts are also not very good at showing more than one dimension. In order to see all of my different regions, I have to create a separate pie chart for each one. Not a bad choice if I'm interested in looking at each one independently, but not so great for comparing the regions to each other. Luckily, there's a better way. A 100% stacked bar chart converts a measure value to a percentage of a total measure. It ends up showing the same information as a pie chart, but it's much faster at showing a second dimension for comparison. Now that we've talked about some basic chart types, I do want to show you some more advanced chart types. These examples have a lot of insights that we can learn, and I'm not going to have time to go through all of the details, but I definitely recommend that you do some research and learn a little bit more about them if your interest is piqued. Our first example that we're going to look at are maps. We're all familiar with these. We see them every election cycle and every time we bring up Google Maps. They are obviously used when there's a geographic element to the data. This example shows when the first leaves appear on trees in spring in the United States by region. Network diagrams show connections between things. These are useful when you're trying to identify interesting patterns, clusters, or outliers. Here, we have a network that relates European languages. There are clusters that have been labeled: Romance, Germanic, Slavic, and other outliers caught between these. The line connecting two dots tells us something about the strength of the relationship. Also, remember the bubble charts? The size of the circles here shows how many people speak that language. Heat maps use color to represent a value of a measurement. It's particularly useful when looking for patterns. For example, this heat map shows where people click the most on a website. In this case, it's Facebook. Red shows where there are more clicks, and green shows the lowest clicks. If we're designing a website, we can use this kind of information to make the best user experience by understanding how they're using what's already there. Tree maps are used to show many dimensions of data and include a hierarchy. We can use this to identify or unify consultants. Using the services we offer as our highest level of our hierarchy, we can break it down into our different capabilities and show how many consultants claim that is their core competency. Sankey diagrams, also sometimes referred to as flow maps, are used to show movement. In this example, we have income streams on the left for an individual. It all flows into one node, which is the budget. Then the expenses flow out from the budget. I especially appreciate how this person has a bucket called buying crap I don't need. I'm pretty sure this is a category worthy of any household budget. And finally, we have box plots. Box plots show information about a distribution of a variable. You might remember these if you've taken a statistics class at some point. These are often used in financial markets and are helpful for data scientists doing data exploration. In this example, we can see the distribution of Olympian ages by sport. You can learn much more about all of these different visualization types, as well as many more, at datavizcatalog.com. Now that we know a little bit more about the basic chart types and maybe we're really interested in getting started and doing some visualization, we need to understand what tools we have available to us. So let's take a look at some of the technologies that we often use here at Unify. First, let's acknowledge that Excel can do a lot. It's a great place to get started in prototyping for a data visualization. It's where we can mock up some data, we can even mock up our visualizations, and most importantly, we can tell if it's going to help us tell the story we want to tell. The more common way that we actually do data visualization is in a platform application. And there are a bunch of different options of what we use here. These applications have data connectors, the ability to write calculations, and they have built-in native chart types, including many of the ones that we looked at today, plus many others. Let's take a look at two of the most common ones that we use here at Unify, which are Power BI and Tableau. Each application has its trade-offs and its advantages. Power BI is highly integrated with Microsoft products and is less expensive to get started with. It's free to start using the desktop application, and costs are relatively low when starting to scale. Feature updates are published each month. Tableau has a beautiful user interface, but the licensing costs are a little bit more expensive upfront. New releases are published 3 to 5 times per year, and the degree of customer support is extensive. There are other applications out there as well, which we can see from the Gartner Magic Quadrant for analytics and BI. Microsoft and Tableau are leading the charge in great data viz tools, and they're regularly releasing better and cooler features. This is a space that is consistently changing and evolving, and it's a really exciting time to be part of it. You'll get to use some of these tools during the hands-on data visualization lessons. Be sure to reference this slide when getting ready for the next Data Viz live session. You'll want to have these ready to go so that you can get the most out of our time together. And finally, feel free to check out some of these other resources if you're just dying to learn more. And that's a wrap. I'm Laura Ludwig, and this has been Data Visualization. I hope you're excited to start telling stories with data.